All right, so we're doing 3.3, discovering the exponent laws. Let's start. What is 2 to the exponent of 2? By the way, this means multiply, if you haven't seen this before. But 2 to the exponent 2 multiplied by 2 to the exponent 4. What does that look like? Well, 2 to the exponent 2 means I got to multiply 2 by itself twice. 2 to the exponent 4 means I have to multiply 2 by itself 4 times. Remember I said that this means multiplication? So why don't I just replace it with an actual multiplication sign? Hey, this looks familiar. This looks like something in expanded form. How do I put it back in exponential form? Well, all my bases are the same, and then I just have to count how many times it's multiplying by itself. And it looks like 2 is multiplying by itself 6 times. You could do the same thing with negative 5 to the exponent 3 and negative 5 to the exponent 6. And I could just show you that very quickly. If you have negative 5 and it's multiplying with itself 3 times, and then if you also have negative 5 and it's multiplying with itself 6 times, wow, that's more negative 5s than I thought I would have to draw. How many negative 5s do you have in total? Well, base is negative 5. I count them all up, and it looks like I'm going to have 9 of them. So this is actually called the multiplication rule. And the multiplication rule states that when multiplying powers with the same bases, you keep the base the same and you add your exponents. And we can see that. 3 plus 6 is 9. And in this example, 2 plus 4 is 6. So keep your base the same, add your exponents. We got a couple of examples here. So I'm going to go through a mental checklist as I go through each of these problems. Do I have the same base? Check. Am I multiplying? Check. So I keep my base the same, and I add my exponents. Let's go to this one, not this one, but rather this one, down here. Remember, if you can't see an exponent, the exponent is 1. Go through your checklist. Do they have the same base? Check. Are they multiplying? Check. Keep your base the same, and then add your exponents. Let's go to this one over here. So for this one, I got 3 terms that are all multiplying. They all have the same base. So check and check. Keep my base the same and add all of my exponents. I think you guys can do this one on your own, so I'll leave that. I think you guys can do this one on your own, so I'll leave that one. Let's do this one together. Can't see the exponent for this last term, so I put a 1. I have 4 W's. They're all multiplying together. So I keep my base, and I add my exponents. And I should get W to the 11. Okay, let's keep going. Now, when you have division, what does that mean? Well, it's really similar to multiplication, but your division rule states that when you're dividing powers and they have the same base, you actually subtract your exponents. So let's do some examples together. Oops, I think I went a bit too far. This time, your mental checklist is going to be, do I have the same base? Check. Are they dividing? Check. So now I can actually keep my base and subtract my exponents. For this one over here, I do the same checklist. Do they have the same base? Check. Are they dividing? Check. Keep my base the same. Subtract my exponents. I think you can do this one. Now, with this one over here, the only difference is that they've written it a little differently. But you just have to tell yourself, this is the exact same thing as this. It just looks a little different. Either way, it's division though. So you ask yourself, do they have the same base? Check. They both have x as their base. Are they dividing? Check. They're dividing. So you keep your base the same and you subtract your exponents. For this one, remember, you can't see an exponent here. So the exponent is 1. I think from there, you guys should be able to handle this one. Let's have a look at f. Same base, yes. Division, yes. Keep your base the same. Subtract exponents. You'll get x to the 0. This is not the same thing as x, because remember, if you just had x, what this actually means is, hey, you can't see an exponent, exponent's 1. But is it? It's not really. We just figured out that it's actually 0. There's an interesting rule in math, and the rule says that anything to the power of 0 is actually 1. And you can test this on a calculator. Remember, a variable is just a placeholder for some number. We talk about this in 3.4. But let's actually assume that we put some number in our calculator. If I raise that to the exponent 0, it's going to be 1. And that'll be true for any number that I put here. Any number raised to the exponent 0 is always 1. That's actually so important that I'm going to write it down. Always. So make sure you guys write that down as well. All right, that'll be part 1. I'll see you guys in part 2.